In this lesson, we're going to learn some of the fundamentals of FreeCAD by building our first project, a simple dollhouse table. The first step is to open FreeCAD. When we first open FreeCAD, we're greeted by a startup page. At the top, we have several common options for starting a new project. I'm going to click Parametric Part, which will create a new FreeCAD document and open the Part Design workbench. The basic workflow of the Part Design workbench is first creating 2D sketches, and then using those sketches to generate 3D features. Let's start creating our dollhouse table, beginning with the tabletop. In the upper right of the toolbar, I'll click Create Sketch. We're then prompted to choose a base plane for our sketch. We can select a plane either by clicking on one of its edges in the viewport, or by selecting it from this list. I'm going to choose the XY plane, and then press OK to begin the sketch. When we create a new sketch, it contains the vertical Y-axis, the horizontal X-axis, and the point where they meet, called the origin. We can add geometry to our sketch using this group of tools in the toolbar, called the sketcher geometries. Let's add a line to our sketch with the line tool. The rule when using these tools is click to start, and then click to finish. We don't click and drag to create geometry. If I try clicking and dragging, I still have to click again to finish the tool. Notice that when I click to start a new line, a blue highlighted box appears. If I want, I can enter a number on my keyboard and then hit the Enter key. I'll enter 40. Enter key. We've just set the length of our line. Now if I want, I can enter a value for the angle of the line. Or I can click again to finish the tool. I'll just click again to finish the tool. It's important to remember that inputting the length and angle when you draw the line is optional. These are things that can be specified later. After adding geometry to the sketch, we can move it around by clicking and dragging. I can click and drag on a line to move the whole line around. I can also click and drag on the endpoint of a line. Notice that when I clicked and dragged on the endpoint of the line with the set length, the other endpoint followed along behind it. With the other lines, I was able to move the endpoints independently. This is because the line with a set length has a constraint. You can think of a constraint as anything that limits our ability to move and change geometry. Because of the length constraint of this line, we can no longer move the endpoints independently like we did with the other lines. To illustrate this further, let's introduce yet another constraint. I'm going to constrain the endpoint of this line to be coincident with or exactly on top of the origin. I'll do this by clicking the endpoint, then holding the Shift key and clicking the origin. Holding down the Shift key allows you to select multiple points or lines. With both the endpoint and the origin selected, I'll click the Constrain Coincident button in the Sketcher Constraints section of the toolbar. Now, when I try to click and drag on that endpoint, I can't move it at all. It is constrained to be exactly on top of the origin. When I click and drag on the other endpoint, all I can do is move it in a circle. If I now select the X-axis, hold Shift and select the free endpoint, then click Constrain Coincident, it'll constrain this endpoint to sit exactly on top of the X-axis. Notice that its color changed to indicate it is completely constrained, and I can no longer click and drag on any part of that line to move it around. Before we go any further, we should ensure that the Auto Remove Redundant Constraints option is turned on. When we are editing a sketch, we can see a list of all current constraints in the combo panel on the left, as well as a drop-down list for settings related to constraints. I'll find the Auto Remove Redundant Constraints setting and ensure that its box is checked. We've seen how to add constraints. We can also remove constraints by selecting them in the viewport or by selecting them in the drop-down list and pressing the Delete key on the keyboard. I'm going to delete all the constraints currently in the sketch. We can also draw a selection box by clicking and dragging. I'm going to select all the lines I've drawn and delete them. Now it's time to define the shape of our tabletop. Clicking the drop-down arrow next to the rectangle tool will show some variations, including centered rectangle. As before, I click to start the tool and click to finish, with optional width and height constraints along the way. With the centered rectangle tool, the point where I click to start will be the center of the rectangle. And if I click to finish, the finishing point will be a corner. I'm going to start the tool exactly at the origin so that the rectangle is centered at the origin. And for demonstration purposes, I'm not going to enter a width and height along the way. As you can see, the centered rectangle tool has created a rectangle as well as some automatically generated constraints. The two lines at the sides of the rectangle have the vertical constraint. The top and bottom have a horizontal constraint. And the top right and bottom left corner points have a symmetric constraint. Let's hover over the Constrain Symmetric tool to get a tooltip to learn more about the symmetric constraint. Constraint Symmetric. Create a symmetry constraint between 2 points with respect to a line or a third point. I'm going to press the Escape key to go back to the Select tool. Now I'm going to click and drag on the corners and sides of our rectangle to see how we can move and stretch it. Then I'm going to select and delete the symmetric constraint to see how this changes what we're able to do to the rectangle. Now I'm going to recreate the symmetric constraint. The Constraint Symmetric tooltip specified that we have to select 2 points and a point of symmetry between them, or 2 points and a line of symmetry between them. I'm going to select the 2 corner points and the origin by clicking while holding the Shift key. Then I'll click the Constraint Symmetric tool to apply the constraint. Now I'm going to finish up this sketch by specifying the width and height of our rectangle. I can do this by clicking the Constrain Dimension tool, then clicking on one of the horizontal lines. I'll click again, then enter a value for the width. I'll choose 80 for now. I can do the same for the height by just clicking on one of the vertical lines with this same tool active. I can place my dimension wherever I want, click, and then enter a value. I'll enter 40. Notice how the color changed once the sketch was fully constrained. Here's a question to test your understanding. Why is it that I only needed to explicitly set the length of one of the horizontal lines and not both? Why did I only need to explicitly set the length of one of the vertical lines and not both? Pause the video and try and come up with an explanation. The answer is, in a word, constraints. Specifically, we have the vertical and horizontal constraints in the sketch to thank for this behavior. Once we set the length of one of the horizontal lines, since the two connecting lines are vertical, the horizontal line on the opposite side must have the same length as the one we specify. The same is true for the vertical lines. We've finished our first sketch. Pause the video and see if you can create a centered rectangle with constraints just like this one. When you're ready to move on, click Close to close the sketch and move on to our next step. After we close the sketch will still be selected. This is convenient because it allows us to immediately select a 3D feature to generate from the sketch if we want. We can deselect the sketch by clicking off of it in the viewport, and select it again by clicking it in the model tree in the combo panel. Before we turn our sketch into a 3D tabletop, let's use the navigation cube to adjust our view. You can click on the faces of the cube to reorient the camera. I'm going to click the top front edge, then the right corner of the navigation cube so that I'm viewing our sketch from above and to the side. This will help us get a better view of the next operation. With the sketch selected, I'm going to click the Pad tool. The Pad tool creates a 3D feature, in this case an extruded solid from a sketch. We can specify the height of the resulting solid by entering a value for the length in the Pad parameters dialog that appears in the combo view. We won't worry about the other parameters for now. I'm going to enter 4 mm for the length, then press OK to finish the tool. And with that, we have our tabletop. In addition to the navigation cube, I can reorient the viewport camera with my center mouse button and the Shift key on my keyboard. Clicking and dragging on the center mouse button will rotate the camera about whichever point was first clicked. Holding Shift while clicking and dragging on the center mouse button will pan the camera or move it laterally. Finally, scrolling the center mouse button will zoom in and out. Pause the video and practice moving the viewport camera with your navigation cube and mouse. See if you can inspect every side of the tabletop before moving on. When designing a part in FreeCAD, it helps to stay organized to make going back and editing easier. In the model tree, I'm going to give our first pad feature a more descriptive name by left-clicking it, then choosing Rename. Let's call it Tabletop Pad. I'll hit the Enter key to apply the new name. Now let's move on to the legs of our dollhouse table. My plan is to create one sketch that will define the profile and position of the legs, then use the Pad tool again to make all 4 legs at once. This will save time and reduce complexity compared to making a sketch and pad for each individual leg. I'll move the camera so I can see the bottom face of the tabletop. I'll select the bottom face by clicking it. Then I'll click the Create Sketch tool to create a new sketch on this face. Before we start creating geometry, let's think about how our table legs need to be positioned with respect to the tabletop. We don't want the legs to be flush with the outer edge of the tabletop. We want them to be inset a bit so that the tabletop will extend past the legs at the corners. In this case, a good tool to start with will be, once again, the centered rectangle tool. I want to create a centered rectangle that will help us position our table legs. However, I don't want this rectangle to be part of the final geometry of the sketch that gets turned into a 3D feature. To achieve this, I'll press the Toggle Construction Geometry button to switch from normal to construction geometry. Notice how the color of the geometry tools changes. This serves as a visual reminder that the geometry we create while construction geometry is active will not be part of the output geometry of the sketch. Now I'm going to create a centered rectangle, centered on the origin. As I'm making it, I won't enter in values for the width and height. I'll simply click to start and click to finish. My idea for this construction rectangle is that I can now place a normal geometry rectangle at each corner, and these will serve as the output geometry for the legs. For these, I'll use the default rectangle tool, not the centered rectangle tool. Again, I won't enter in values for the width and height as I make them. Let's start constraining this sketch by constraining the width and height of the table leg profile rectangles. Let's suppose we want the legs to have a square profile and for all the legs to be the same shape. To codify these two requirements with constraints, let's first select a vertical and horizontal line from each of the 4 rectangles. I'll hit Escape to go back to the Select tool. Once again, I'm holding Shift to select multiple elements. Now I'll find the Constrain Equal tool and click it. We've just made it so that the width and height of all the rectangles are the same, and that the rectangles are all congruent to each other. Now if we constrain the height or the width of any of these rectangles, all the rest will follow suit. Note that you can change a length constraint after creating it by double-clicking it. I'll set the width to 10 millimeters. Pause the video and get your sketch up to date with all the geometry and constraints we have added so far. We've almost finished our sketch for the table legs. Let's move our sketch geometry around to get an idea of what else needs to be constrained. We can also see in the Solver Messages box in the Combo panel that our sketch is under-constrained and that it has 2 degrees of freedom. You can think of a degree of freedom as something about the sketch that can still be moved around. In this case, our 2 degrees of freedom are the width and the height of our construction rectangle. I could finish the sketch by specifying the width and the height with length constraints, like so. But let's consider what we would need to do if we wanted to go back and revise the width and length of our table. We would have to make changes to our original sketch for the tabletop, and then change these length constraints in this sketch as well. Since our primary design concern for the position of the table legs is how far they are inset from the tabletop corners, Let's make that the way we constrain their position. I'll delete those length constraints. So in order to do this, we'll first need to somehow include two of the edges of the table in our sketch. This can be achieved with the Create External Geometry tool. We'll find the Create External Geometry tool here in the toolbar. I'll click on the edges I want to include in my sketch. When you include external geometry, it'll be added similar to construction geometry. It won't be included in the final output geometry. Now we'll create two more construction lines, like so. I want the endpoint of this line to be constrained to be on top of this new line I've created. Notice I've also created it so that it comes prepackaged with a horizontal constraint. A horizontal constraint gets automatically applied to a line if you draw it close enough to horizontal, and the same with vertical. We need one more construction line. Now I'll constrain these two construction lines equal. What this has done is it's made it so that the table legs are the same distance away from the length and width edges. Now I'll apply a length constraint to either one of these lines to define how far the table legs are inset from the edges. I'll enter 5 millimeters. Now our sketch is fully constrained. Pause the video and get your sketch up to date with these changes. When you're finished, press close to close the sketch. Once again, with the sketch selected, I'll click the Pad tool, and this will create our legs. I'll enter in 60 millimeters for the length. I'll give our pad a more descriptive name by right-clicking, going to rename. I'll call this one Leg Pad. Now, as you can see, our dollhouse table looks a bit out of proportion. Fortunately, we can go back and make adjustments to any point of the model tree, and the model will automatically rebuild after each change. Let's start with the base sketch, where we'll make our table wider and longer. I'll go to where my tabletop pad is. I'll click the little arrow on the side, which should show me the sketch that this pad is based off of. I'll double click, and that'll take me back to that sketch. Maybe I'll change the 80 millimeter width to 100 millimeters. And maybe I'll change 40 to 60. I'll hit close. Now you can see our table has automatically rebuilt. We can also see that our legs are still positioned exactly how we want, inset from the edges. I think I'm okay with the thickness of the table, but maybe the legs could be a little thinner. I'll click the little drop down arrow for the leg pad to access the sketch it's based off of. Double click. I'll change this length constraint from 10 to 8. We'll see how that looks. I'll hit close. Yeah, that looks a bit better. Pause the video and adjust the width, length, and height of your table however you want. When you're finished, you'll be ready for the last step. I'm noticing that there's a lot of sharp corners on our table, which isn't ideal for something that's going to live in a dollhouse. The easiest way to round off sharp corners is with the fillet tool. First, I'll select an edge that I want to round off. Then I'll click the fillet tool. This brings up a dialog in the combo view where I can add additional edges to be rounded and change the size of the fillet. I'm going to add the other 3 corner edges of the table and set the fillet radius to 4 millimeters. I'll push the select button, click on the other corners in turn, I can see now that there are 4 edges listed here. I can click preview to get a quick preview, and I'm going to increase the radius to 4. That looks about right. I'll hit OK. I'm going to name this fillet table corner fillet. Now, let's see what happens when I select just one edge of the tabletop and apply a 1 millimeter fillet. The fillet was automatically applied all the way around the table edge. This behavior is a result of the fact that we placed fillets at the corners previously. I'll add another 1 millimeter fillet to the underside edge. I'll hit preview again. Looks good. I'll hit OK. Now, as a challenge, see if you can add a 1 millimeter fillet to all of the long edges of the table legs. Pause the video and give that a try. Well, we'll start by selecting one of our edges, clicking the fillet tool. Now we've got to go through and select the rest of our edges. I'll orbit around. And I'll do a quick preview to make sure I didn't miss any. Yeah, looks good. I'll hit OK. And after that, our dollhouse table is complete.